8.4 Basic Concepts of Probability. In this section, we'll determine the probability of more complex events. I'm going to start with what is known as the addition rule for probability. For any event E and F from sample space S, P probability of E union F is equal to the probability of E plus the probability of F minus the probability of the intersection of EF. The above in words says the probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Although the addition rule applies to any events E and F from any sample space, the derivation we have given is valid only for sample spaces with equally likely simple events. What does that mean? Well, we'll find out. So, when playing American roulette, the attendant spins a marble that lands in one of the 38 slots of revolving turntable. The slots are numbered 1 through 36, with 2 additional slots labeled 0 and 00 that are painted green. Half the remaining slots are colored red and half are black. Okay? In roulette, the slots labeled 00 or 0 are not considered even or odd. Finding the probability that the marble will land. Find the probability that the marble will land in a red or even number. So let's start with red. So let R be the event that the marble lands on a red slot. Let E be the event that the marble lands on an even slot. Okay? So we have 38 slots and half of those are color red or black. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18 are red. Then PR, which is probability of landing in red, equals 18 out of 38. Also, the probability of ending in an even slot should also be 18 out of 38. So let's find out. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So yes. Okay? So now we must find an intersection. Finally, to use the addition rule for probability, we need to find the intersection, which would be P of R intersection E. So let's find out both red and even. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 out of 38. So now we can finally do our math. Therefore, P R E is equal to PE plus PR minus PR intersection E. So that's going to be 18 out of 38 plus 18 out of 38 minus 8 over 38, which equals 14 out of 19. Woo! Now, suppose two fair dice, plural is a die, are rolled. Find each of the given probabilities. So before we read, we must find the sample space. So the sample space remembers all possible outcomes. So it's 1, 1, one roll, one die lands a 1, the second die lands a 2. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So this represents the first die. This represents the second die. Okay? So now I have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay? So, that's our sample space. Now let's read the question. The first die shows a 2. So let's highlight first die shows a 2. So let's highlight. Sorry about that. So that's all the first die shows a 2. Okay? Equals A. Then it says the sum of the result is sum of the result is 6 or 7 for B. So we're going to get all sums that gives me 6 or 7. So that's going to give me 6, all these, and all these are going to give me 7. Okay? So you're using our math. So P A union B is equal to PA plus PB minus PA intersection B. So then for PA, we have 6 out of 36. For PB, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 36. And PA intersection B is equal to these two guys right here. So it's going to be 2 out of 36. So 6 out of 36 plus 11 out of 36 minus 2 out of 36 is equal to 15 out of 36, which equals to 5 out of 12. So that was A. Now B. B says the sum is 11. So P sum is 11. So let's get a highlighter again with a different color. So P is a highlighter. Sum is 11. So these guys are the ones that will give you the sum of 11. So that's going to give you 2 out of 36. And the second die shows a 5. So P second die shows 5. Equals. So let's get another highlighter. And that's going to give me all of these. So that's 1, 2, 3, 4, 5, 6 out of 36. And that's for this. Now we need to find the intersection. So P sum is 11. Intersection, second die shows 5. And that's going to be 1 out of 36 because it's just that one. So we have 2 out of 36 plus 6 out of 36 minus 1 out of 36 equals 8, 7 out of 36. Now, if events E and F are disjoint, then E intersection F is equal to an empty space or empty set. By definition, hence 0. The probability would be 0. Okay. So assume that the probability of a couple having a baby boy is the same as the probability of the couple having a baby girl. If the couple has 3 children, find the probability that at least 2 of them are girls. So we're going to do our sample space again. So that's a boy, that's a girl. And we're going to do this 3 times. We're going to do it a little bit smaller because I'm not running around out of space. So boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl. Okay? So following the pattern, we have boy, 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 boy. Then we have boy, boy, girl. Then we have boy, girl, boy. And then we have boy, girl, girl. Then we have girl, boy, boy. Then we have girl, boy, girl. Then we have girl, girl, boy. And we have girl, girl, girl. Okay? Now, if the couple has to be shown, find the probability that at least 2 of them are girls. Well, this one has 2 girls, this one has 2 girls, and this one has 2 girls. But it has at least. That means they can all be girls too. So those are our probabilities. Okay? So we have that P at least 2 girls is 4 out of 8. Which equals 1/2. Or, using the theorem above, we can also say that P at least 2 girls is equal to P 2 girls plus P 3 girls. because it's still false. So how many we had? 3 out of 8 for girls, for 2 girls, and we had 1 out of 8 for girls, which is 4/8, which equals 1/2 as well. Now, complement rule. For any event E, the probability of the complement of E is equal to 1 minus the probability of E, and the probability of E is equal to 1 minus the probability of complement of E. So if a fair die is rolled, what is the probability that any number but 5 will show up? So first of all, let's do our sample space. 1, 2, 3, 4, 5, and 6, because we're only doing 1 is rolled. Okay? Now, let E be the event that any number knows. So we're going to say that 5 comes up. Then we're going to have the pre-complement of E, which is 1/6. And to find the answer, we're just going to do the complement of 1 minus 1/6, which equals 6/6 minus 1/6, which equals 5/6. Okay? Now, that was one way of doing this. The other way of doing it is, the probability says that any number but 5 will come out. So how many do we have that are not 5? 1, 2, 3. 1, 2, 3, 4, 5. So we can also say 5 out of how many? 6. Either way, you get the correct answer. Okay? So if 2 fair dice are rolled, again, 2 fair dice, so let's do our sample space again. 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay? So, find the probability that the sum of the numbers showing is greater than 3. So, 1 plus 1 is 2, so that's not. 2 plus 1, those are 3. So, from here, this that I'm circling are all sums greater than 3. Okay? We know that we have 36 possible outputs. So our answer would be 33 out of 36, which equals 11/12. That's the easy way for me. Okay? Now, using how the book wants, or how they want us to do this one, we can do this. The P of the sum is less than or equal to 3. Then we have the P of the sum is 2 plus P of the sum is 3. So for 2, that's 1/36 plus 2 out of 36, which equals 33 out of 36, which equals 11/12. That's the same answer. Now the long and tedious would be sum 4 So how many of those equal 4? So that's 3. Sum 5 out of 36 plus sum 5. So that's 5, 1, 2, 3, 4 out of 36. Sum 6, 5 out of 36. Sum 7, 6 out of 36 plus sum 8, 5 out of 36, sum 9 plus 4 out of 36 plus sum 10 is 3 out of 36, 11, 2 out of 36, and 12, 1 out of 36. If we add all this up, we're going to get 33 out of 36, which equals 11 out of 12. Whatever floats your boat. Sometimes probability statements are given in terms of odds. A comparison of probability of E with probability of complement of E. Example, assume probability of E is equal to 4/5. Then the probability of the complement of E is equal to 1 minus 4/5, which equals 1/5. Thus, the probability predict that E will occur 4 out of 5 times, and the E complement will occur 1 out of 5 times. Then we can say the odds in favor of E are 4 to 1. And we following the example from the theorem below, we do that, and we do the math, and we have 4 over 1. 4 to 1. Okay? So suppose the weathercaster says that the probability of rain tomorrow is 1/3. Find the odds in favor of the rain tomorrow. Okay, so we have that the probability of the event of rain is 1/3. So we must find, using the complement rule, the no rain. So the event of no rain, or the complement of E, will be 1 minus 1/3, which equals 3 out of 3 minus 1/3, which equals 2/3 of no rain. Now, using the odds example, we have 1/3 over 2/3 equals 1/3 divided by 2/3. Then we have 1/3 times 3/2. Remember to use the reciprocal. So the odds are equal to 1 to 2. Also can be written as 1 to 2. If the odds favoring event E are m to n, then we have the below. So let's do number 7. Austin weather forecasters given probability in terms of percentage. Suppose the weather forecast said that there is a 40% chance that it will snow tomorrow. Find the odds of snow tomorrow. Okay, so we have 40% is equal to 0.4, which equals 4 out of 10. And that's the probability of snowing. Now we must find the complement of that, means no snow. So we have is equal to 1 minus 4 over 10, which equals 4 over 4 minus 4 over 10. Sorry, it's not 4 over 4, it's 10 over 10. Equals 6 over 10. And this is no snow. So we have 4 over 10, 6 over 10 equals 4 over 10 divided by 6 over 10. which can be rewritten as 4 over 10 times 10 over 6. And we have 2/3, which equals 2 to 3. Okay? Example 8. The odds that a particular bit will be low bit are often 4 to 5. Find the probability that the bit will be the low bit. Recall previous theorem. If the odds favoring event E are m to n, then the probability of the event is m plus n. And the complement of that, n over m plus n. Okay? So A the odds that a particular bit will be the low bit are 4 to 5. So odds, find the probability that the bit will be the low bit. So the odd of 4 to 5 is, we are doing the event. So we have 4 over 4 plus 5, which equals 4 over 9, which equals 4 to 9. Now B, find the odds against the bit being the low bit. So pretty much we're going to be doing the complement. So E equals not low bit. So that's why we must do 1 minus 4 over 9. That's going to give me 9 over 9, which minus 4 over 9, which equals 5 over 9. Okay? Therefore, P not low bit over the probability of low bit is equal to 5 over 9 over 4 over 9, which equals 5 over 9 divided by 4 over 9, which equals 5 over 9 times 9 over 4. So we have 5 out of 4. Let A represent the driver in a fatal vehicle accident was age 24 or younger. Let B represent the driver had a blood alcohol content of 0.08% or higher. From data on fatal crashes in the year 2015, blah, 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 we have the following probabilities. PA is 0.8882, PB is 0.1648, and the intersection of both are 0.0330. This is 24 or younger. BAC of 0.08%, and that's the intersection. So, to maintain this a little bit easier to read, let's do a Venn diagram. So this is PA, this is PB, and we know that both is 0.0330. Okay. So to find PA in the Venn diagram, we have that PA is 0.1882, but we're going to subtract that by 0.0330 because we're already using that part. So that's going to give me 0.1552. Same thing for probability B. Probability B states for 0.1648 minus 0.0330 equals 0.1318. Okay? Okay, so we have everything here. We also need to find anything outside. So that's going to be probability A plus the probability B plus intersection of B is equal to 0.552 plus 0.0330 plus 0.1318 is equal to 0.3200. Now we're going to find the complements of the intersections. That's going to give me 1 minus 0.3200 equals 0.6800. So here we have 0.6800. So I think we're ready. So find the probability that the driver was 25 years or older. So 25 years, so that's the complement of A. And has a BAC level below 0.08. So that's also the complement. So guess what? This is our answer. The complements. So we're done with that. B. Find the probability that the driver has a fatal crash is 25 years older or probability of 25 older or a BAC of below 0.08%. So we have 0.68 plus 0.138 plus 552 equals 0.9670. And it was just filling in the blanks because the Venn diagram gave us all the information we needed. This concludes 8.4.